Using De Moivre's theorem and the binomial expansion of cosine theta plus I sine theta to the fifth power, or otherwise show that cosine 5 theta is equal to 16 cosine to the fifth theta minus 20 cosine cubed plus 5 cosine theta. So because you want cosine 5 theta, that's going to equal to the real part of cosine theta plus I sine theta raised to the fifth power. So let's expand cosine theta plus I sine theta to the fifth. So that's cosine to the fifth plus 5 cosine to the fourth I sine plus 10 cosine cubed I sine raised to the second power. That's 10 cosine squared I sine raised to the third power. And then 5 cosine I sine raised to the fourth plus I sine raised to the fifth. Now, because we're interested in the real part, we can eliminate those that have I raised to an odd power. So that's going to be every other term. So we just need to focus on the ones that are not crossed off. So then cosine 5 theta is going to equal cosine to the fifth plus, and then actually minus 10 cosine cubed, 10 cosine cubed sine squared plus 5 cosine sine to the fourth. And now we need to make a substitution and say that sine squared is 1 minus cosine squared. So we'll replace that to get everything in terms of cosine. And then for sine to the fourth, that's sine squared squared. Sine squared is 1 minus cosine squared, so we're going to square that. And so we're going to distribute the negative 10 cosine cubed. So it's negative cosine cubed plus 10 cosine to the fifth, and then plus 5 cosine theta, 1 minus 2 cosine squared plus cosine to the fourth. So we'll distribute the 5 cosine next. And actually, we can combine the 10 cosine to the fifth with cosine to the fifth to get 11 cosine to the fifth. So these two get combined, and then we have plus 5 cosine theta minus 10 cosine cubed plus 5 cosine to the fifth. And so we can add the 11 cosine to the fifth with the 5 cosine to the fifth to get 16 cosine to the fifth. And then we have negative 10 cosine cubed, negative 10 cosine cubed, that's negative 20 cosine cubed, plus 5 cosine theta. And so we were able to show that this holds. So then in part 2, we want to show that the real part of e to the I pi over 10 is equal to the square root of 5 plus square root of 5 over 8. So for this, we know that the real part is equal to cosine of pi over 10. So we want to use this equation to solve for it. So take that equation, and we're going to let theta equal pi over 10. So we have cosine 5 times pi over 10 equals 16 cosine to the fifth pi over 10 minus 20 cosine cubed pi over 10 plus 5 cosine pi over 10. Now, cosine of 5 pi over 10 is the same thing as cosine of pi over 2. That's going to be 0. And the nice thing here is that we know that cosine pi over 10 is not equal to 0. It's going to be a number that's slightly less than 1. So I can divide both sides by cosine pi over 10 since it's not equal to 0. At this point, I cannot factor this out. This doesn't work out nicely. It's not factorable. So instead, I'm going to use a quadratic formula. So you can think of this, if you want, if you let u equal cosine squared pi over 10, that's 16u squared minus 20u plus 5 equals 0. So I'm going to let u equal, then we do opposite b plus or minus the square root of b squared minus 4ac over 2a. So that's 20 plus or minus, let's see, 16 times 5 is 80 times 4 is 320. 400 minus 320 is 80 over 2. So 80 is 16 times 5. So if I bring the 16 out, it becomes 4. And so this is, oh, the 2a. Sorry, I forgot this has to be 16. So this will be 32. That's also 32. So if I divide everything by 4, 20 divided by 4 is 5. And then 4 divided by 4 is 1. That's the square root of 5. 32 divided by 4 is 8. But because here I'm interested in getting cosine of pi over 10, we're only going to consider the positive version of it. So we're only going to consider 5 plus square root of 5 over 8. Even though they're both positive, we only care about 5 plus square root of 5 over 8. And then u we said was cosine squared. Now when I take the square root of both sides, we typically get plus or minus. Actually, but here it's actually cosine squared of pi over 10. So let's replace that with pi over 10. And we don't want to get negative because cosine pi over 10 is positive. So we're going to do the square root of 5 plus square root of 5 over 8. And so we were able to show that.